Hello everyone, today we are going to discuss about the spectroscopy, which is important for the upcoming examination of your RPSC first grade and set examination, net examination. And also there is an important note for the RPSC first grade examination students that previously in the RPSC first grade that IR, UV and NMR was given in your syllabus. However, this time they have incorporated the Raman, ESR and mass. They have added these three spectroscopic techniques in your syllabus. Also, they have changes that the application portion in the application in terms of structure elucidation. The structure elucidation. Okay, so there will be questions regarding to your basic idea of spectroscopy and then structure elucidation of the spectroscopy. So today we are going to discuss about basic idea of spectroscopy, wherein we will discuss about the definition, principles and spectrophotometers diagram, as well as the different kind of spectroscopy, their basic idea in this class. Okay, so let's start with the definition of the spectroscopy. So what is a spectroscopy? Basically, the spectroscopy is a technique or a branch of science that study how the matter interact with electromagnetic radiation. How the matter interact with the electromagnetic radiations, right? Or in simple terms, how the substance absorb, emit or scatter light to the learn about their composition and structure. So the basic definitions is how electromagnetic radiation interact with the matter. If we are going towards a little bit scientific definition, then the definition of spectroscopy will be given as that spectroscopy a branch of science or which deals with the transition that a molecules undergo between its energy level upon absorption of suitable radiation, and those radiation will determined by quantum mechanical selection rule. Okay, so that is a basic definition of the spectroscopy. Okay, so in your examination there is no such type of question that they will ask you write the definition of the spectroscopy, but you will keep in mind that okay, that is a definition of the spectroscopy. So how it is works, that is important. How the spectroscopy works? Basically, the spectroscopy works based on the quantum principles. Okay, so quantum principle was used in order to explain the spectroscopic terminology. So whenever we see that molecules, that is the samples that contain molecules, will absorb or interact with the electromagnetic radiations that is fall on the substance or the samples, and then they will absorb or emit or scattering the energy at specific wavelength. Each substance has their own unique arrangement of the electron energy level when light falls on it. Okay, and then they emit certain wavelength or scatter the light. So by studying these wavelength of these transmitted light, we can identify the substance and learn about the structure. So let's try to understand the basic principle of the spectroscopy. Okay, so to understand this principle, we have two molecular energy levels. That is, these are two molecular energy levels, and these energy levels are designated as En and Em. Right? En defined as a ground state energy level, and that is excited state energy level. Okay, so what happened as when a photon of frequencies, now a photon that have frequencies nu fall on the substance, that have frequencies nu, that fall on the substance or molecules in the ground state energy, and its energy is equals to E is equals to h nu, right? That energy is exactly equal to the energy difference of delta E, that is equals to excited state energy level and ground state energy level, right? And then between the two molecular energy level, then the molecule undergo transition from lower energy to excited state energy. Okay, so that transition from lower energy level to excited energy level or higher energy level with the absorption of photon of energy h nu. So E is equals to h nu. That photon will absorb, that spectrum shows as absorption spectrum. Okay, and the spectrum, if the molecules fall from excited state to ground state, then the emission of a photon of energy that contain E is equals to h nu. The spectrum obtained is called emission spectrum. Right? So that is the basic principles of every spectroscopy, right? So in order to find out the structure of any compound or the molecules which was given as a samples, we need to find out the spectrophotometer, and the spectrophotometers have some basic skeleton or the basic features. So let's try to understand how the basic structure and the skeleton of spectrophotometer works. As we mentioned that we need a source of energy as a quantized, that is source for absorption or the emission by the samples, and there is a samples which was taken, and after that after the absorption some amount of wavelength which was absorbed by the samples and some amount of wavelength which was transmitted by the samples reached to the modulars. What modular do with those wavelength? Modular will improve the detection by reducing the signal to noise ratio. Okay, so that it is easy for the analyzer to optimize or to identify the specific selected wavelength. Okay, and then those wavelengths sent to the detector. The detector will detect the transmitted radiation and convert those radiation into the signals, and those signals sent to the recorder, and recorder will record the signals and give the printout to us. After that we can easily find out the particular wavelength frequencies which was missed, easily can be seen in the graph, and we can easily print out, we can figure out that okay, this particular wavelength was missed, and thereby our functional group or our particular atoms present in the substance or the molecules. Okay, so that is a basic spectrophotometer, the skeleton which is present into all spectroscopy photometers, whether it is NMR, UV, IR, any kind of spectrophotometer, they have working on these principles. Okay, so now let's try to understand what are the basic spectroscopies are they available for the structure elucidation, and which are the spectroscopies are available in your syllabus. So in your syllabus there are NMR, RPSC. I am talking about particularly RPSC first year examination. So there is NMR available, ESR they have added, rotational IR spectroscopy they have already given, Raman spectroscopy they have added, UV spectroscopy it is mentioned in your syllabus. So you need to understand the basic idea about all six spectroscopy. So first of all we need to understand the region of electromagnetic spectrum. Okay, we know that each and every molecule have their energy levels, that is quantized energy level. Okay, so for that particular energy levels we need a different kind of energy sources. So in which region they are working efficiently. So the region for the NMR is a radio frequency region, and the wavelength for the particular region is given 1 meter to 10 to the power 3 meters, and the frequency for particular spectroscopy region is 10 to the power 6 to 10 to the power 10 8 hertz. Now, the source of radiation is radio frequency oscillator or radio frequency coil. Condition for the NMR active molecule, the nuclear spin have I naught should be 0. Okay. And the key uses or the usefulness of NMR spectroscopy is in order to identify the nuclear environment or structure elucidation of any compound. Okay. After that, the ESR spectroscopy. In the ESR spectroscopy works in microwave region, and those region have wavelength of 1 millimeter to 1 meters, and the frequency range 10 to the power 9 to 10 to the power 11 hertz. Those have source of radiation is a klystron or the gun diode, and the condition for the ESR active molecule, there should be unpaired electron must be present in the molecules, and the usefulness of ESR is to identify the unpaired electron or the paramagnetic substance. The rotational spectroscopy that is also work in the microwave region, and the wavelength are those for the particularly work in the rotational spectroscopy 1 millimeter to 1 centimeter, and the frequency region is 10 to the power 9 hertz to 10 to the power 12 hertz, and the source of radiation is a microwave generator. Condition for the rotational spectroscopy molecule, that permanent dipole moment should be required. And what we can measure, or what kind of information we get from rotational spectroscopy, that molecular structure such as a bond length. Okay, the IR spectroscopy basically work in the IR region, that is belongs to 700 nanometer to 1 millimeters, and the frequency region 10 to the power 11 to 10 to the power 14 hertz, and the Nernst Glover as used as a source of radiation. Condition for the IR active molecule is a change in the dipole moment during the vibrations. The information what we can get from the IR spectroscopy, the functional group and the bond vibrations we can get. And the Raman spectroscopy, that is work in the visible or near IR region, and that wavelength has a 400 to 1000 nanometers, and the frequency region 3 into 10 to the power 14 to 7.5 into 10 to the power 14 hertz. And laser sources basically used for the source of the radiation. Condition for Raman active molecules, that change in the polarizability, and the information we get the molecular vibration or the structure conjugation, particularly for the non-polar molecules. And the UV visible spectroscopy is the belongs to UV visible region, and the wavelength for UV spectroscopy, that is 200 to 800 nanometers, and the frequency region is 3.75 to 10 to the power 14 to 1.5 into 10 to the power 15 hertz. And the source of radiation is tungsten lamp, and the unsaturation should be required for UV active molecules, and the conjugation or unsaturation can be identified by the help of UV spectroscopy. Now these are the remaining spectroscopy we are not going to discuss here, because this is for particularly RPSC first grade examination. Yes, what, like, okay, I have mentioned several things regarding the different spectroscopy. Now you will think about, there is a no like use of region, there is a no use of recalling this data, there is a no use of remembering the frequencies. No, that is completely wrong, because nowadays there is a questions which are directly asked related to the wavelength, related to their frequency. So we need to keep in mind that okay, we need to at least remember two or three spectroscopic frequency data at least. Okay, so they will ask directly in the examination, as we will discuss in the question section. Okay, number 2, the electromagnetic spectrum order. You should be remember, okay, that in the like for example, the we are like writing this order for your kind of references, and there is also a trick which was given in order to remember this electromagnetic spectrum. Okay, you may also prepare the trick by your own. Okay, now let us discuss the question portion, that how this particular chart will help you to solve this question. The first question, the match the item of list 1 with those in list 2 and indicate the correct answer from the code given below. Okay, so the question is type of radiation and frequency range in hertz. Okay, as I mentioned that they asked this kind of question in the previous examination also. So they have given the four spectroscopic radiation and therefore hertz frequency ranges. So first, microwave, x-rays, infrared and ultraviolet. There are two options. Okay, there are two things, two way that you can solve this question. First, electromagnetic radiation order. If you have order in your mind, then you can easily solve this question. For examples, I have remember that order of first of all radio wave, after that microwave, after that IR, after that visible, after that UV, and after that X-rays, right? So that is the order of energy, and that also order of frequencies, because energy is directly proportional to the frequency. So the frequency order asked in the exam in the question. So first, which have the most or highest frequency, that is X-ray. So X-ray is highest frequency, that is 10 to the power 18. Okay, so the B is going to be 1. Okay, so let's see which option showing that B is going to be 1. That is option B. Okay, number 2, after that there is a UV, visible, IR. Okay, microwave. So lowest for the microwave, so find out the lowest value. The lowest value is the 10 to the power 9 to 10 to the power 11. So A is going to with 4. So which option is showing? A is going to be 4. So A 4 and B 1. Now how you differentiate C and D? So among like between C and D, IR and UV, which have higher energy, that is the UV. So UV is going with 3, that is this one. Okay, so that is the first way which help you to solve this particular question. But if you think that you are not interested to recalling these data, okay, so you will definitely get trapped by this question. Okay, so that is a simple question. Which the frequency region 10 to the power 12 to 10 to the power 14 hertz belong to which region of the electromagnetic radiation? Now your order getting fail. Okay, fail. Now you have to remember at least 2 or 3 frequencies. Okay, so let's see this. The frequency region of IR 10 to the power 11 to 10 to the power 14 hertz, that belong to IR region. So the question was asked 10 to the power 12 to 10 to the power 14 hertz, that belongs to the which region? That belongs to the IR region. Okay, the third question is that is related to the condition for the molecules. Okay, match the item of list 1 with those of list 2nd and identify the correct answer from the given code. Microwave active, IR active, rotational Raman active, vibrational Raman active. Okay, so for examples, if we don't have idea about the rotational Raman and vibrational Raman, right? Okay, before, because the Raman spectroscopy added this time, and suppose in case you are confused, then this particular question can be solved with the help of option A and B. So let's see. First, microwave active molecules. Okay, so microwave active molecules, we know that they the molecule should be polar, right? So the molecule should be polar in case of microwave active. IR active molecules. In IR active molecules, the electric dipole moment of the molecule must change when atom displays relative to the one another. That is related to the IR active molecules. Okay, so that is also we have mentioned. The IR active molecules change in the dipole moment during the vibration. For the rotational spectroscopy, the permanent dipole moment required. So both conditions we have already studied. Third one, rotational Raman, vibrational Raman. For that we know that for the rotational Raman, the molecule must be an isotropic polarability. That we will discuss in the Raman spectroscopy portion, that what is the anisotropic polarability, and also the vibrational Raman active molecules, that should be polarability should be changed as molecule vibrate. So that is going with the D. Okay, so the correct answer will be the first one. That is, so this is the basic idea of spectroscopy. And what is the purpose of this video? The purpose of this video is, right now the RPSC is going to make a question lengthy, as well as they want to trap the students by making the question like a database or memory based questions, so that student need to be memorize more and more data. Also they are getting confused, like right now the questions which was asked in the RPSC pattern, that is first match 1 and match 2. Okay, so here will be questions regarding to, like they will give the four statement. First statement will be related to the UV spectroscopy. Second will be IR spectroscopy. Third will be NMR spectroscopy, and fourth will be Raman spectroscopy. Now there will be true, false. Okay, so that type of patterns RPSC following this time. So I have made it a lot of question series based on this type of questions for your help. Okay, so in the upcoming videos I will give a basic layout of all spectroscopy, and based on that UV, IR, NMR, ESR and mass spectrometry, I will provide you a lot of practice questions, so that it will help you a lot, and there will be definitely chances that this type of questions you will get in your examination. So let's stay continue and connected through this YouTube channel, so that you will get updated by the latest content. Thank you very much.